Privacy on the blockchain is important, but not so simple to understand. To understand privacy in terms of blockchains, we need to look at how blockchains handle transactions. Let's jump in. Blockchains like Ethereum and Bitcoin are essentially public ledgers. Every transaction is recorded and can be viewed by anyone. For example, if Alice sends 1 ETH to Bob, the transaction details such as the amount sent, the receiver's address and the sender's address are stored in the blockchain and visible to everyone. Here is the catch. While addresses and transaction details are public, they don't directly reveal your identity. As long as you don't tell anyone that you own a particular address, linking it to your real-world identity requires a significant effort. However, patterns can emerge. For instance, depositing to or withdrawing from a central exchange can often reveal key information. By analyzing these transaction patterns and other transaction activities, it becomes possible to link blockchain addresses to real-world identities. And this is where privacy becomes a major concern. For smart contracts, everything is public, including the code itself, the owner, and the state of the contract. This transparency is one of the defining features of blockchain technology. It ensures that anyone can audit the contract, verify its functionality, and trust that it will execute as written, with no backdoors. This transparency comes at a cost. Sensitive data, like user interactions with the contract, balances, or specific actions are also publicly available. This means while smart contracts enable trustless interactions, they can expose private details about the user, making privacy a significant challenge in DeFi. Now that we understand the challenges of privacy on the blockchain, let's explore the solutions. Starting with privacy-focused blockchains. 3 of the most known examples are Zcash, Monero, and Secret Network, each using unique approaches to achieve privacy. Zcash is a blockchain that gives users the choice between 2 types of transactions: transparent and shielded. Transparent transactions work just like the ones on the Ethereum or Bitcoin, where details like sender, receiver, and transaction amount is visible to everyone. If we look at a Zcash transaction on Explorer, we can see the sender's and receiver's information as well as the amount sent. Shielded transactions, on the other hand, uses ZK-SNARKs to hide all transaction details. ZK-SNARKs are an advanced topic, so don't worry about the technical details for now, but we may cover them later. Here is a shielded transaction on Explorer. With shielded transactions, even though the blockchain verifies that the funds are valid and the transaction follows the rules, it does so without revealing who sent what to whom and the amount. Only the fee, the date, and the transaction size is revealed. This makes Zcash a powerful tool for those who need privacy. Monero, however, takes a different approach by focusing privacy on all transactions. Unlike Zcash, where privacy is optional, Monero ensures that all transactions are private by default. As you see in the Monero Explorer, no information related to sender, receiver, or the amount is shown. Only the fee, date, and transaction size is public. Transacting with Monero doesn't reveal the recipient's holdings to the sender, even though the sender knows the receiver's public address. Monero transactions are unlinkable and untraceable. Coins sent to a recipient are rerouted through an address that is randomly created specifically for this transaction. Let's go step by step how Monero transactions work. Let's say Alice wants to send 5 XMR to Bob. By the way, XMR is the native token of Monero. Bob has a public address that he shares with Alice, so she can send him XMR. However, Monero doesn't send funds directly to this public address. Instead, Monero generates a unique one-time stealth address specifically for this transaction. This stealth address is created using Bob's public address and Alice's private key, ensuring that only Bob can identify and access the funds. Anyone looking at the blockchain will see the stealth address, but they won't know it's connected to Bob. When Alice sends 5 XMR, Monero uses a feature called ring signatures to hide the fact that the funds are coming from her address. Here's how. The transaction is grouped with other transactions on the blockchain, called decoys. These decoys are selected randomly from the previous transactions, making it impossible to determine which one is the real source of the funds. Even though Alice initiated the transaction, her address is indistinguishable from the decoys, protecting her identity. Now, Monero hides the amount being sent. Instead of displaying 5 XMR on the blockchain, the 5 XMR is split into smaller amounts, and Monero encrypts each amount. Then, Monero uses advanced cryptographic proofs to verify the total without revealing the amount. As a result, anyone looking at the blockchain cannot see how much Alice sent to Bob, or even who they are. Monero's strong focus on privacy makes it highly secure, but it also has raised concerns with authorities because it could be used for illegal activities. Monero is still seen as one of the best options for people who want maximum privacy. While Zcash and Monero focus on transaction privacy, Secret Network takes privacy to the next level by introducing privacy at the smart contract level. Unlike Ethereum, where all smart contract data is public, Secret Network uses encrypted inputs, outputs, and states for the contract. This ensures that sensitive data like user information or financial details remains private. We will dive deeper into the underlying mechanism of Secret Network and other privacy solutions like zero-knowledge proofs, mixers, and tumblers that can be integrated to public blockchains like Ethereum to provide privacy in the upcoming videos. Until then, take care.